Good morning, dear students. Welcome to the online session of chemistry. Hope you all are safe and fine at home. Let's recap what we have discussed in the previous session. In the previous session, we have discussed about a brief history of chemistry, where we have discussed how human beings have made efforts to lead a better life. How they have searched for different ways to improve clothing, building materials, and also developed various agricultural products to improve agricultural yield. Then we have discussed that in ancient times, alchemy was the term used for chemistry. We have discussed that alchemists had two main aims, that was converting the cheaper metals into gold, that is copper. The metals like copper and iron can be easily converted to gold. And also they believed that there is elixir of life. So they kept searching for elixir of life, though their belief was proved wrong as it was scientifically wrong. Then we have discussed that alchemists accepted the Greek belief that everything on this earth, or you can say in this world, is made up of mainly the four substances, that is earth, fire, air and water. Well, the origin of modern chemistry disproved the four-element theory. Lavoisier performed an experiment, and this experiment proved that water is made up of simpler substances. Now what he did in an experiment was a mixture of hydrogen and oxygen was taken together, and when it was ignited, means it was burned, the mixture exploded, means it burst, and water droplets were formed. So this experiment proved that water itself is made up of still simpler substances, that is hydrogen and oxygen. Then we have discussed about Mendeleev, who presented the periodic table of elements. What was the need of this periodic table of elements? Well, in the discovery of various experiments, or in the discovery of various elements, there were so many elements discovered by various elements. So it became very difficult for the scientists to classify them or to study them. So they tried to present or classify these elements to study it in a better way. And Mendeleev presented the periodic table of elements. Then we have discussed about atoms and molecules. We have discussed that atom is the smallest part of an element which takes part in a chemical reaction. But this atom is so small, or you can say it is indivisible particle, that it cannot exist independently. So what does it do to become independent? It may combine with other atom or atoms of the same element, or maybe different elements, to form a molecule. Now, as you have learned in the previous session about how modern chemistry evolved, let us now discuss about the life and work of its founding fathers. First of all, let us discuss about the famous scientist Robert Boyle. He was called the man of science, the man of faith. His full name was Robert William Boyle. He was born to a noble family on 25th January 1627. His father was Richard Boyle, and Robert Boyle was the seventh son of his parents' 15 children. That means altogether Robert Boyle and his brothers and sisters were around 15 children, and Robert Boyle was the seventh son of his parents. When he was 8 years old, he was sent to Eton College. Just have a view of this Eton College. It looks great. The building is so good. So, at the age of 8, he was sent to Eton College. This was a boarding school for boys in England. He studied here for around 6 years. And when he was about 14 years old, he set out on a long journey with his tutor. Tutor means the headmaster or the teacher. After spending about 4 years touring and studying in different parts of Europe, just have a view of Europe. So he moved around in this Europe. He did touring and also studied in the different parts of Europe. Then he returned to England. Robert Boyle was very much influenced by the great scientist of that time, Galileo Galilei. He studied Galileo's work, and it was Galileo only who shaped Boyle's life and directed him towards science. But Galileo's death triggered an interest in Boyle to study Galileo's work. This was one of the things that helped Robert Boyle to develop a passion for science. And thereafter, Boyle devoted his life to scientific research. He performed a number of experiments and was able to discover a lot of elements. Robert Boyle soon became an important member of the Invisible College. Now, what is that Invisible College? It sounds something which is not visible. Well, Invisible College is the term for a small community of interacting scholars. That means a group of scientific research scholars, or you can say a group of scientists who often met face to face. And when they met, whatever experiments they performed, they exchanged those ideas. And whatever discovery was made, whatever result they have got, was encouraged by each one of them. So this way, whatever experiments were performed by them and whatever result they got for those experiments were told to each other, and they encouraged each other at that time. In fact, this Invisible College was exactly not a college but a society, and a society of those who pursued the new philosophy of science. in this invisible college only, and it was this invisible college only which was made the Royal Society by the king of that time in 1663. And Robert Boyle was made a fellow of this society, that is an FRS. Now what is FRS? What do you understand by FRS? It is fellowship, or you can say membership of the Royal Society. Then for few years Boyle did his research work in Oxford University. Let's have a view of the Oxford University. The building is very good. Well, we can see it only from outside right now. And this Robert Boyle, he did his research work in Oxford University. When he started growing old and his health started failing, what did he do? He left all his work and went back to London and lived with his elder sister. He refrained himself from all the public affairs. That means he stopped himself from all the public affairs and spent his time doing only research. Boyle carried out his research in various subjects. So, it was not only chemistry that he was interested in, but there were various other subjects. Let's see. His interest was in physics, chemistry, oceanography. What is oceanography? It is the scientific study of the ocean. He was also interested in gemology, which means the study of precious stones. And his interest was in blood science. And there were many more fields. He was the first scientist to have prepared a substance simpler than water, which was later established to be hydrogen. Robert Boyle also rejected or disproved Aristotle's theory. What was Aristotle's theory? That water is an element, which was an old belief of Greeks that water, air, earth and fire are elements, and everything in this world is made up of these four substances. So, the discovery of hydrogen disproved the four element theory. Then, Robert Boyle made important contributions to physics and chemistry, and he is best known for Boyle's law, which describes an ideal gas. Now, what did he do? Boyle studied the behavior of gases, that is, how the gas behaves under certain conditions. So, what did he observe? He observed that at a fixed temperature, the volume of a gas decreases and the pressure increases. And at the same time, he also discovered that at a fixed temperature only, the volume of the gas increases with the decreasing pressure. That means, if we keep the temperature fixed, the volume of gas may differ. And how it will differ? Due to the pressure. If the pressure is increasing at the fixed temperature, the volume of the gas will decrease. And if the pressure is decreasing, the volume of the gas will increase. This was only called as Boyle's law. Then Boyle also authored a number of books. So around 20 books of different aspects of science were authored by Robert Boyle. One of his famous books is Skeptical Chemist, which means doubtful chemist. In 1670, Boyle had a stroke which left him paralyzed, but he recovered slowly from this and his health was better. But finally, Boyle died in 1691 on 31st December in London. Now, let's move on to the next founding father of chemistry. He was Antony Laurent de Lavoisier, the father of modern chemistry. He was born in a noble family in Paris on 26th August 1743. He studied at the University of Paris and graduated when he was about 20 years old. His special interest was in chemistry, botany, astronomy. Now, what is astronomy? The scientific study of science, sun, moon, stars, etc. And his interest was also in mathematics. Lavoisier, he created the first modern chemistry textbook. Now, he also worked, means his special interest was there in so many subjects, but still he was a working man. Only in his spare time he was doing research work. So, what he did, what was the job he was doing? He joined a tax collecting company on contract basis with the royal government. This was the company that collected tax on goods which were transported to and from Paris. And Lavoisier pursued his scientific research only in his spare, that is, in the free time. His main contribution to chemistry was that he changed the nature of the subject from qualitative to quantitative. For example, suppose one observes that hydrogen reacts, or you can say combines with oxygen, it forms water. So this observation is only qualitative in nature. That is, hydrogen, one substance, is combining with oxygen, that is another substance, and it forms a new substance. So what Lavoisier did was he proved that by weight, 1 part of hydrogen combines with 8 parts of oxygen and forms 9 parts of water. This observation was considered quantitative in nature. So what was proved in this observation? It was proved that hydrogen and oxygen are simpler substances of which water is made. And this was considered the quantitative nature of the combination that took place between hydrogen and oxygen. Now let's see the contributions of Lavoisier. His first contribution was he identified hydrogen and oxygen. Though hydrogen was first obtained by Robert Boyle and oxygen was obtained by Priestley, but as an element it was identified by Lavoisier. He also proved that a substance burns only in the presence of oxygen. That means if a substance is to be burned, it needs the presence of oxygen. And he also proved that while burning, a substance combines with oxygen. Then his next contribution was he suggested the metric system of weights and measures. That is, he suggested that meter is the unit of length and kilogram is the unit of weight. He also established that sulfur is an element, not a compound. Sulfur is the 10th most abundant element in the universe. So, in 1777, Antony convinced the group of people of his scientific community that sulfur was an element. Then, he also predicted the existence of silicon. That was another contribution of Lavoisier. He suggested a better system of naming the elements and compounds. Then he suggested that matter may change its form or shape, but its mass will not be changed. For example, ice, that is the solid form of water, may change to liquid form of water, but its mass before and after the change will remain the same. It's not going to change. He brought revolution in the scientific world with a multitude of experiments. Means by doing so many experiments, he brought a revolution to the scientific world and a single principle that will govern the physical world forever. He believed that in any transformation or a change, no amount of matter, no mass is even lost, and nor it is gained. Means if a transformation or a change is taking place, neither it is losing any amount of matter nor it is gaining any amount of matter. That means matter is neither created nor destroyed. Now let's move on with the next founding fathers of chemistry. He was John Dalton. He was born on 6th September 1766 in England. He got his primary education in a rural school, a village school. His parents were very poor to support him any further for his studies. So what did he do? At the age of 12, he started a teaching job in a school. Later, he became a teacher in a college at Manchester. So, from childhood, he was sent to a school which was in the village side. He got his primary education from the rural school. And because his parents could not support him study further, he started doing a teaching job. And with this, he moved on and later in his life became a teacher in a college at Manchester. His field of interests were various. Many fields he was interested into. He studied literature, mathematics, meteorology, that is the science that deals with weather, and also his special interest was for chemistry. In 1800, he left his job at the college and became the secretary of the Literary and Philosophical Society of Manchester. Then, in 1817, he was elected the president of this society, and he also, like Robert Boyle only, became a fellow of the Royal Society. Fellow means the member of the Royal Society. He was very much interested in meteorology and therefore he maintained the weather record. That is, maintained a record of temperature and humidity for many years. During that time, there were no aeroplanes, or you can say the weather balloons. Aeroplanes were also not there, and the weather observation balloons were also not there. So what did he do? He climbed up hills to make his observations at different heights. He climbed hills to make his observations at different heights, and at the age of 27 he published a book based on his own set of observations. That was Meteorological Observations and Essays. He was Dalton only who laid the foundation of modern science by advancing his atomic theory. He gave atomic theory in 1803. Now, what is atomic theory? And what are the important features of this theory? As you have already studied about the concept of atoms, we have discussed that atom term was proposed by Democritus. This term comes from a Greek word atomos, which means indivisible. So, all the forms of matter is made up of these particles called atoms. This atom was considered to be the smallest unit of all forms of matter. The first scientific theory about atoms was given by John Dalton only. He said that atom is a solid, hard sphere. It is neutral in nature. That means it has no charge over it. So according to Dalton, an atom is a solid sphere, and he also gave some other points about atoms. So, in his atomic theory, according to Dalton, it was proved that all matter is made up of tiny particles called atoms. For example, a wall is made up of bricks. Similarly, all forms of matter is made up of tiny particles called atoms. Another example, if you take a small piece of banana and take a bigger piece of banana, when you taste both of it, you will find that it tastes same. Similarly, if you take a small piece of watermelon, it tastes the same as the entire bigger piece of watermelon. But does a banana taste like watermelon? No. They are different. Similarly, all atoms of the same element are alike. So if we talk about gold and silver, all the atoms of silver are alike, and all the atoms of gold also are alike. But they are different from each other. Then, if we talk about a group of children in a school, you know that you cannot fix any number to that. It can be any number. Similarly, if there is a number of people sitting at a tea stall, this can be also any number. You cannot fix any number to it. But when we talk about a cricket team, say the Indian cricket team, we know a fixed number of players play a match. Similarly, when atoms combine, they combine in fixed proportions to form compounds. So, compounds are formed when atoms of different elements combine in fixed proportions. So, if we talk about hydrogen and oxygen atoms, that is, when two hydrogen atoms and one oxygen atom combines, it forms water. So these atoms, they will always combine in fixed proportions to form compounds. So the atoms of different elements, whenever they are combining, it is combining in fixed proportions and it is forming compound. And in this example, you have known that hydrogen atoms combine with oxygen atoms in fixed proportions to form compound. Now, let's take another example. If we are given 4 materials, that is bricks, cement, marble and granite, and we have to make different structures and buildings from these, you know that just by rearranging these materials in different forms, we can form a number of different structures. You can form buildings, pyramids, even Taj Mahal. The basic materials will remain the same. That is, it will remain brick, granite, marble and cement. The only thing which is taking place is the different arrangements are taking place of these particles, which enables you to form a number of different structures. So, in a chemical reaction also, it involves rearrangement of the atoms and not a change in the atom. these atoms, they remain the same. But whenever a chemical reaction is taking place, these atoms, they rearrange themselves. The basic building blocks, that is the atoms, do not change. They only rearrange themselves to give a chemical reaction. So according to Dalton, what takes part in a chemical reaction? According to Dalton theory, it says that atom is the smallest particle of all forms of matter. Hence, atom is the indivisible or the smallest particle that is taking part in the chemical reaction. Then, moving further, about 20 elements and 17 molecules were listed in Dalton's book entitled A New System of Chemical Philosophy. This man was an unmarried man, and unfortunately he's also suffered 3 strokes. He suffered 3 strokes between 8 years, that is from 1837 to 1844. He suffered from 3 strokes, and he was dead on 27th July 1844. And in his funeral ceremony, more than 40,000 people came to Manchester to pay their last respect to the departed genius. Now let's move on to the next important scientist. He is Mendeleev, Dmitry Ivanovich Mendeleev. He was born in a village in Siberia, which is a part of Russia, on 8th of February in 1834. He went to a school near his village itself. Later, he got admitted to St. Petersburg University, from where he graduated at the age of 20. At the age of 30, he became professor at the St. Petersburg University, where he obtained his DSc degree. DSc means a postdoctoral degree that is awarded to people who made exceptional and outstanding contributions to the world in their particular field of study. Well, although PhD, that is Doctor of Philosophy, is considered as the highest degree in many parts of the world, DSc is one step above PhD. Mendeleev's fields of interest were varied. He studied chemistry, physics, and geology. Geology is the study of rocks and the way they are formed. Well, though he made valuable contributions to physics as well as geology, he is best known for the classification of elements. As you have learned in the previous session, that in search of the philosopher's stone and the elixir of life, alchemists discovered more and more elements. So, with the discovery of a large number of elements, scientists found it difficult to study the elements. it became essential for the scientists to classify them. So, by 1863, the number of elements known had risen to 56. So, what did scientists do? They tried with all possible efforts to arrange the elements, and this classification involved keeping similar things together and dissimilar things apart. Many attempts were made by different scientists to classify them, but they did not get complete success. So, in 1869, Mendeleev put forward his periodic table. He presented a table called the periodic table of elements, which he himself revised in 1871. He brought similar elements together in a column and called it a group, and dissimilar elements apart, that is, in different groups. His periodic table also helped him predict the existence of three elements which are now named as scandium, gallium and germanium. Mendeleev, he studied the origin and composition of petroleum as well. Now, what is petroleum? It is an underground deposit from which we get petrol. He strongly believed that petroleum should be used to obtain chemicals rather than for burning. And he was one to establish the first oil refinery in Russia. He also studied how liquids expand when heated. He was the one of the founders of the Russian Chemical Society. He was awarded Davy Medal and later the Copley Medal by the Royal Society of London, and he was elected a foreign member of the Royal Society. In honor of his contribution to chemistry, the element which is placed in the 101st house of the periodic table is named as Mendeleevium. So, with this, we end up today's session. Hope you stay safe, stay protected, and enjoy this learning experience. God be with you all.